All right, so we're starting section 2.4 today, talking about complex numbers and the different operations you can do with complex numbers. So today we're just going to get into just kind of an introduction into the complex numbers. And we're going to start off by reviewing how to simplify a radical. So first learning target, I can simplify each expression to the simplest radical form. So your success criteria, the first thing you want to do is make a factor tree. So a factor tree is when you start with a number in the radical. So for number 1, we have the number 27, and then we break it down into factors. So 27 can break down to 3 times 9. 3 times 9 is 27. And then 9 breaks down to 3 times 3. And I know my tree is complete because all of the n numbers are prime. Now, after I've completed my factor tree, I'm going to circle pairs. So I'm looking for pairs of numbers. So I have a pair of 3, 2 3s there. So I'll circle those. And these pairs, when we break it down, the pairs are going to go outside of the square root. And then with the singles left over, stay inside. So pairs go outside the square root, and singles stay in the square root. All right, let's try another one. So square root of 50. Start by breaking down the 50. I can do 5 times 10, or if you wanted to, you could start with 2 times 25. It doesn't matter. You'll end up with the same prime numbers. So from there, I can do 2 times 5 here. So here's my pair. My pair is 5. So the 5 comes out. Single is 2. Single stays in. Try the next one. So I'll do 8 times 10. And then I'll break down 8 to 2 times 4. And 4 to 2 times 2, and 10 to 2 times 5. Here's a pair of 2s, here's another pair of 2s, and a single of 5. So remember, pairs go out, so I have 2 times 2, 2 2s, and then a single of 5, that stays in. So my final answer is 4, because 2 times 2 is 4, square root 5. All right, so let's go down here to this essential question. How can you represent and operate on numbers that are not real on the number line? Well, that's where imaginary numbers come in. So you can, with imaginary number, and the imaginary number is called or represented by the fancy I. Okay, so let's take a look at this imaginary number. So now we're on page 27 of the note packet, and we're going to look at this first. We're going to skip down to here, this little ribbon. It says the number square root of -1 is called the imaginary unit I. So I equals the square root of -1. And then I squared equals -1. So these are important to know. I equals the square root of -1, and I squared equals -1. So let's look at some roots here with negative numbers. So that brings us to our next learning target. I can simplify roots of negative numbers. Okay, so let's look at some success criteria here. So you're going to start these off by defining your root here. So you're going to rewrite this negative root in terms of I. So if you're given a negative root, so we'll just call it b, square root of negative, and then we'll call the number b here. This is written as square root of b, I. All right, so what this means, let's look at this one down here. This is like saying the square root of 16 times negative 1, which is the same thing as saying the square root of 16 times the square root of negative 1. And then we know that the square root of negative 1 is I. So you can rewrite this as the square root of 16I. All right, so that's what it means when it says rewrite square root of negative b as square root of bi. Now we're going to make a factor tree, just like we did before. So we're going to make a factor tree for that b squared. So for the 16 here, we're going to break it down. That's 4 times 4. And you might have already known that without making a factor tree. The square root of 16 is plus or minus 4. All right, and then bring down that I, and that's your answer. So after you make the factor tree, remember that pairs go outside. So our pair of 4 came outside. And we didn't have any singles, so the square root just dropped off there. So pairs go outside the square root, singles stay in. Just like we did in the last example. All right, let's look at the next one. So I'm going to rewrite this as the square root of 24i. And then I'm going to break it down all the way till all the numbers are prime. And then I'll circle my pairs here. And then these would be my singles. So pairs go outside. So the 2 comes outside, and then the singles stay in, 2 and 3. So 2 times 3 is 6. And then I. Okay, last one. So for this one, I have 2 square root of 75i. And I could do 3 times 25, and then 5 times 5. There's my pair. Now for this one, I already have a number outside, so I'm going to take my pair and multiply it to that number. So I'm going to go 5 times 2 is 10, and then the single will stay in. All right. So 10 square root of 3i. Okay, let's go back up to the top here. And we're going to do our next learning target here. I can solve a quadratic equation using square roots. Okay. So we have the problem x squared equals 16. So what you would do, you would first take the square root of both sides, square root both sides, both sides of equation. Okay, so that looks like this. Square root of x squared square root of 16. Now when you take the square root of a square, those cancel each other out. So let's make a little note here. The square root of x squared just equals x, because the square and the square root cancel out. So over here, if I take the square root of x squared, that's just x. And then I know that the square root of 16 is 4, plus or minus 4. And then that would be my answer. So we took the square root of both sides of the equation and then we simplified. Okay, let's look at this one now. So step 1 is to take the square root of both sides, and we know that the square root of x squared is x. And then I have plus or minus the square root of -9. So we know that when we take a square root of a negative number, we have to rewrite it so it's in the form of that number squared, I. And then the square root of 9 is 3. So that's the answer right there. All right, let's go down to the bottom of this page and try some more. You can pause the video and try these on your own. All right, let's see how you did. So we take the square root of both sides. This would be just simplify down to x. And then this would be the square root of 5i. And I'll see if I can break that down. I can't make a factor tree because 5 is already prime. So that's my answer there. Next one, square root of both sides. Square root of 72i. This one can break down. So I can do 6 times 12. And then I can do 6 times 2 here. And I already see a pair, so I don't have to keep breaking down my tree. I can just recognize that as a pair there. And I'll bring that out. My 2 stays in. And then, of course, my I at the end. And that's the answer. All right, so that is it for today's lesson. And now you're ready to work on your worksheets.